All right, I'm David Bugakorot. I work for Puppet Labs. I've been there for about 2 years. That's me on Twitter, and I think most of you can't see my email address. It's kind of sad. Apparently Bill Gates sends you money just for forwarding an email. Include me in that. That's why I have my email address on there. Before I started at Puppet, I was at Red Hat for a very long time, and as part of my job there, I actually came across Puppet really early on, like late 2005, 2006 or something like that. And kind of the thing that really struck me was this vision of making configuration something that you can share, that's not just tied down in documents and all that. And working with Puppet more, one of the things I thought is generally a problem, at least administering Unix systems, and kind of Puppet brought to the forefront, is that it's really hard to twiddle configuration files a lot of times. So I wrote a little tool called Augius, which that gives you a way to, basically gives you an API to make changes for configuration. So if you're still changing your configuration files, like set and grep and arg, stop doing that, check out Augius. I've also recently worked on something called Razor, which Ryan mentioned this morning. And I'm not sure if I should give a little more of a spiel on Razor. There seemed to be a bit of interest this morning on it. In a nutshell, Razor gives you a RESTful API to control PXE provisioning. I don't know how many of you actually provision bare metal machines. Can you just? Wow. Yeah, I'm always blown away by that. There's still a fair number of people who deal with that. When I started at Puppet 2 years ago and was asked to start looking at Razor, I was like, it's ridiculous. Who still does PXE provisioning? It's all cloud and Word, and nobody needs that anymore. I couldn't have been more wrong. So what we've done is, if you've heard about it, Razor was had made a pretty big splash about 2 years ago at PuppetConf here in San Francisco, where the guys from EMC, Nick Weaver and Tom McSweeney, who initially wrote it, gave a talk about it. A lot of people really liked it. And so when I came on at Puppet then took over that code base because Nick and Tom realized they didn't really have the resources to run an open source community, and they had no venue for productizing that. So when I came on and looked at it, I really liked the ideas behind it. Some of the implementation choices I wouldn't have made, and so we decided to rewrite it. And today Razor uses Postgres as its database. It's written in Ruby. We use something called TalkBox, which is basically a Ruby application server. So the stack is much more standard, in terms, very similar to any other web service than it was before. So we've worked on that for the last year and a half or so. Some other changes we made was it's now very easy to add an installer for a new operating system to Razor. Besides the files you need to actually automate the installation of your operating system, say a kickstart file or some other scripts. So besides that, you always need that, of course. You only need to write like a 10-line YAML file or something like that to describe how that installer works to Razor, to bring it into Razor. Before it was a lot harder to do that. And so we've had it in Puppet Enterprise for about a year now in tech preview, which means be really careful and don't use it in production, even though there's intrepid souls that use it in production. They don't really read the warnings on the box. But very soon we're going to have it as a fully supported part of Puppet Enterprise, and I'm really excited by that. It's taken a little longer than I thought it would, but it's really gratifying to bring something from building it all the way to shipping it as product, and I hope people like it. Are there any questions about Razor that anybody has? Yes.
Open source?
Yes. It's open source. It's like it's very similar to how we do Puppet, right? There's Puppet open source, and then we also have the supported Puppet Enterprise offering. And Razor falls into the same vein, where there's an open source Puppet project, and we bundle all that together into Puppet Enterprise. With for Razor, we don't have any commercial add-ons yet. For Puppet, we do. There's a lot of additional functionality, but the basic functionality is an open source Apache license and all that.
So most of the hardware vendors these days, most of the bare metal servers we are getting, they all are coming with their own REST API, right? So like say, I used to do PXE boot on Dell servers. Dell 618, they all have their own REST APIs. And we just have to make a couple of calls REST API, which in turn do a PXE boot and then loads the cloud and of the big store. everything is just happen one single button. We can just invoke a couple of API commands to do everything. I want to understand how different Razor is from using the proprietary REST API from the vendors.
Okay, so yeah, just to abbreviate your question, like how different is Razor? The question is how different is Razor from using like the proprietary whatever Dell API? How different is Razor from using the proprietary API? Depending on what you get from Dell, there might actually be Razor in there. So yeah, I'm not too familiar what the specific API you're talking about. What Razor does in a nutshell is it boots a discovery kernel, which in Razor speaks called a microkernel, but there's no herd or any of that stuff involved. It's really just a little Linux image that runs factor. The node sends back facts about itself. Razor stores in this database, and you set up rules that say, a machine that looks like this should have CentOS. You get the normal standard facts, so you can make decisions based on memory size, how much hard drives you have, those kind of things. But one really interesting example was you can also extend the facts that Razor gathers and then make decisions based on those additional facts. And somebody used something called the LLDP, the Link Layer Discovery Protocol, to figure out what ports on the switch the machine was plugged in. To help them make, I have a rack of servers, the top should be a load balancer, the bottom should be a database, in the middle I want to have web servers to make those sort of decisions. The sky's the limit on what sort of provisioning policy you can express with Razor. And I think that's probably the biggest difference to those APIs. One more, and then I'll move on to Docker.
So I haven't used it in about a year, but one of the big pain points was being able to choose and install different start or .env files. Is that improved at all?
I think so, yeah. If you're talking about the original Razor, you had to actually write some Ruby code to get an installer into the system. Is that the pain?
That's the tech preview Razor.
Okay, then we should talk afterwards what the pain was, because that hasn't changed much, and I haven't heard many complaints about that. That's too painful. You still need to be at a point where you've kind of manually automated the installation of the operating system. But after that, it should be pretty easy to get in there. And if it's not, we should talk. All right. So this was the aside about Razor. Let's talk about. Have you heard about these guys at all? Docker is amazingly, they just had their second birthday party last week. I was it's surprising to think that Docker is that new and has that amount of following and buzz and interest around it. But because it's so new, I think we're still trying to figure out where exactly it fits in and what the right model to use Docker is. There's a debate about should you use a container more like a lightweight VM, which means you run an init system and a bunch of services. I think most people move away from that and look at Docker more as a way to contain the services or isolate the services from other things and follow the kind of one service per container model. But that raises all kinds of questions about how should we adapt processes that we've used in kind of a mutable server world. What tools do we need and how do they need to change and all that. But I think that the point that really hits home with people is that containers give you what everybody wanted from virtualization. Like I remember in the days when virtualization was really new, the big complaint that people tried to address with that was that they had very low utilization of their hardware. Right on Wall Street, if you had like 15% utilization of your servers, you were pretty amazing. And the reason people had such low utilization of their hardware was that they were so afraid that two applications might interact with each other in weird ways. Right? I update some library for this application over here, and now this other application is broken. They were so afraid of that they just put, they never put more than one application on one machine. That's where the low utilization came from. So what everybody saw with virtualization was that, now we can have these virtual machines, put them on the same hardware and drive utilization up that way. What containers tell us is that virtualization is really overkill if all you want to do is have decent isolation between different services, and not isolation in the security sense. There's a great blog post by Dan Walsh about how containers don't contain. Don't let anybody fool you into that containers give you security isolation, but they at least give you isolation in terms of resource usage. You can control how many resources each container gets. They give you isolation in terms of this application uses this version of libxml and that uses that version of libxml, and there's no chance that the two of them interfere in some way. And that's, so in a very real way, I think containers give people what they always wanted to have from virtualization at a much lower cost with a much faster, much quicker, more adaptable tool chain. And they also give you this, because the Artifactory container is so small, it's a nice way to pass that thing through your CI pipeline, right? Generally, they're not much bigger than your main application RPM or whatever would be. Much more lightweight than a virtual machine image would be. So a lot of people just pass that through CI pipeline. You know that the bits you test are exactly the bits you put into production. Those kind of things really resonate. One of the things I hear a lot is that because Docker is immutable infrastructure and it kind of forces people to think more about immutable infrastructure tooling and processes. Does Puppet even have a role in that world, right? Because Puppet is really just about twiddling bits on machines that that are running, and I think that's a fallacy that we definitely furthered over the last 10 years or so. That to have people think of Puppet or configuration management in general as the thing that twiddles running machines in some way. But if you actually look back, and we'll look forward to it, but if you look back, that's not really what configuration was. It's just kind of a happenstance of how these tools were used and written over the last 10 years. So the idea of configuration actually goes way back. There's papers from like the 1950s that talk about configuration management. So the 1950s, right, when there were like 5 computers in the world. People were already worrying about configuration for various things. And so it's a really old concern. And Gareth Rushgrove, who was mentioned earlier and who will be mentioned again in this talk, actually put me onto this really nice definition of configuration and configuration management. And it starts with the insight that configuration isn't just the files and packages and services you're running on your machine. It's really any input into your infrastructure is configuration. And today that includes how you start your EC2 instances, how you build your Docker containers, how you set up your networking gear. All that really is configuration, because all of these things need to be in place and need to be right for things to work for you. Right? It doesn't really matter whether your application is broken because you misconfigured a switch or because your web server is broken. Broken is broken in that sense. So the same sort of control and processes should apply to all these things. And so configuration management then is concerned with managing those inputs, and there's kind of 2 dimensions that make this an interesting problem. The one is time. So you need to manage these inputs over time. Anybody can manage, can install a machine and walk away from it and never touch it again. But that's not how things happen. Things that you want to do are make the changes that go into infrastructure understandable. So you have, say, an audit trail, you have history for how things evolve over time, a way to predict how changes will change the infrastructure in the future. When you make changes, you want to have a way to say, oh, this is going to restart the service over here, or what have you. And the other dimension that makes it interesting is scale. Again, anybody can manage 3 machines manually. You'd be crazy to bring in big config management tooling if all you have to do is deal with 3 machines. You just log into them and do whatever needs to be done. But that gets hard once you hit like 30 machines, say, and by the time you get to 300, you really need some tooling to help you do what needs to be done. And I don't think anybody could ever manage 3,000 machines manually. And so the important point of looking at it that way is that containers and immutable techniques that don't really change those underlying concerns of managing change over time or at scale. They just shift it around a little bit. Yes, your containers run immutable and you might not touch them ever once they're running, but you still need to influence what goes into your image builds, right, rather than what happens at runtime. And as I said, I've known about Puppet in some function for a long time, and I think it's instructive to go back and look at the scary tales, the Scary Campfire tales from what people did before config management was as widespread as it is today, and what they did looked something like this. All your configuration, how you do certain things was written in some documents. If you're a scrappy startup, probably Markdown. If you're an enterprise, DocBook XML. But there were documents that described everything you needed to do. I hope nobody ever actually printed them out. But it was human readable stuff. And kind of the next step was automating some of that. And if you, who knows what this is? If you can read, can you read it?
Kickstarter.
Yeah, it's a little Kickstart file. And I actually encountered something like that a long time ago, doing some consulting for investment bank in Europe, where they were trying to move from doing config management this way. The important thing of this file, which you probably can't see in the back, is that the top is all just fairly boilerplate Kickstarter, set the language of the installer, set a root password, whatever, enable some repositories, pull in some packages, that's all fine, normal Kickstart stuff. But then they would download this big Perl script from somewhere and run that. And that Perl script was actually what did all the work. And I would like to show that to you, but for one, I don't have the Perl script. For two, I was told not to insult the audience. But yeah, so that sysadmin where I was doing the consulting, he showed me that Perl script is like this 1,000-line affair that tries to figure out in what data center the machine is being set up and set whatever NTP settings according to that, and try to figure out what role the machine has and all that. And what they had realized, and what I think everybody who's done this had realized, is that this is incredibly brittle. Every time you need to have a slightly different role of machine or some change, you make that change, and you can be very confident that it works for the new setup because you're using it immediately to set up those machines. But there's zero confidence in whether machines you've set up 3 months before or a year before would still be set up in exactly the same way as they were with this changed script. And when I first started looking at Docker, probably a year ago, the first thing that struck me when I looked at the Dockerfile, which is how you control building a container, is that it looked an awful lot like these Kickstart files that try to do everything. Right? And this is a really, really simple example of what's happening. I didn't mean to pick on Steve there. This is fine, it installs some packages. This is a Dockerfile that sets up a CouchDB. And then here we get into editing some config file. We add our own custom config file for CouchDB, and then we have a command that says how to run CouchDB from this container. And then as a developer, we build a container, stick it in our CI pipeline, whatever. And then we kind of throw it over the fence. We're really proud of what we've achieved, and the ops people just look at this really, really strangely and say, I have no idea what's in this container. What does it do? How does it behave? There's no way for me to know what any of this does. And so as a developer, you're really, really proud of what you've just built, this nice golden container that should just work. What ops people see is more something like this. And when you build your infrastructure with containers like that, this is what happens. Opaque containers and these kind of one-off scripting things are probably not the best idea to do that. So I just wanted to go through how Puppet works real quick, and then we'll get into the meat of the talk of kind of some connections between Puppet and Docker. I think since Ryan did his thing this morning, I don't need to talk too much about how Puppet works, and I assume most people here have some at least basic understanding of Puppet. There's a couple things that are important here. So this is kind of the life cycle of a node or a Puppet run. Right? It starts with a node that sends facts to the Puppet master. The Puppet master has manifests, and it compiles a catalog from that. The node takes the catalog, compares the desired state that's described in the catalog with what it looks like right now, makes any changes that are necessary. Maybe the catalog says HTTPD should be running and it's not running right now, so Puppet will start it. And then it sends back a report to the Puppet master And the report talks about all the things that the node had to do to get into compliance with the catalog. The report gets stored in PuppetDB usually, and that's all great. The catalog also gets stored in PuppetDB, and the facts also get stored in PuppetDB. So just by virtue of having that central server, PuppetDB actually becomes a really, really important repository of your infrastructure. Right, you can now query against PuppetDB which machines are actually running Apache, which machines have this config tweak, all these things you can get out of PuppetDB, which is awesome for, I don't know, rolling out an OpenSSL update if that should ever be necessary. You can at least find, which machines have OpenSSL on them. The other thing that will become important in a little bit is that all this communication is secured with SSL both ways. So the Puppet master, of course, has a SSL server certificate. And that certificate is really just there to protect nodes from rogue masters showing up on your network, because these nodes, the Puppet agent on these nodes can do pretty much anything. So rogue master could be pretty disastrous. But it also, we also require a SSL client certificate on the node to protect the server from somebody just coming in with a laptop and connecting to the master. The reason we do that is that the Puppet master knows a great deal about your infrastructure, might know some secrets, some private SSH keys, SSH host keys, whatnot. We make sure that way that any node only sees the bits about the infrastructure that it's really supposed to see, and not anything else. But because SSL is a bit of a pain to set up, and we'll talk about how that comes to bear on Docker in a minute. I'm sure you've seen the kind of package file service Drfile, which is the most basic thing you can do with Puppet, but it also covers like 80% of use cases. If you've understood this and can describe things in the simple scenario, you've come a long way in becoming a Puppet master. One of the important things is, so here this Puppet manifest describes what we understand as a web server, right? For our side, we say we want this package installed. We have this configuration file that's custom to our side, and we want the Apache HTTP service up and running. One of the things that make config management so useful is that when you're working in a big infrastructure, there's actually not that much variation between things. And so it helps if you can express what's similar and what's different amongst systems in a very concise manner. And one of the ways to do that in Puppet is this class inheritance, where you say this class, this web server 2 class is almost the same as the web server class. All we do here is use a different configuration file. And that's not necessarily the best way to do this. It's the best way to show on the slide. There's other mechanisms, like we heard about Hira earlier. You can parentize classes and all that. But the important thing is that the idea is that when you look at any individual machine in your infrastructure, the setup of that machine is made up of setups for different concerns, right? We talk about how NTP is set up and SSHD and our web server, and I don't know, how we PHP.ini or whatever we do there. And so these things become reusable bits of how we talk about our infrastructure. Config management systems and Puppet have very powerful ways to combine these kind of abstract definitions into concrete systems. If you looked at the Dockerfile earlier, that had a little from line, and you might say, oh, that's a nice way to structure my infrastructure, right? I have more basic images, I extend them to put more specialized things in there. But that only lets you form a tree, right? All Docker images in the world form a tree because you inherit from a base image somewhere, but nothing more complicated. But in a lot of situations, you might need a little more complicated way to put things together from kind of different aspects of how you've described your configuration. So you might have your basic web server set up, and then you have a web server with SSL and a web server with PHP, and then you combine these in a web server that serves SSL and PHP. And if you try to unroll this into a tree of Docker images, you're in a wall of pain. Okay, so much for the kind of high-level abstract things. So the first thing really Docker-specific I want to talk about is managing a Docker host and what goes on there, which is kind of middle-of-the-road stuff for Puppet. That's what Puppet does. In that sense, Docker isn't any different from anything else that Puppet manages. The Forge has been mentioned several times today. Great way to share code and find things that you can automate in your infrastructure easily. If you should never just start writing a module. You should first check the Forge if there's a module for it. Nathan talked about the Gareths Daughter module earlier, which is on the Forge. Right now it's approved, which means it meets certain quality standards. We're actually working on making it supported, and very soon it should actually be a supported module, which means it's part of Puppet Enterprise. You get the same support for this for anything else in Puppet Enterprise. It's under very active development. The last release, 3.3.2, was in early February. It's also immensely popular. So far it's seen 58,000 downloads, 20,000 of those in the last 6 weeks. So there's reason to believe that people find it really, really useful. Some of the things you can do with it are, it can install Docker for you, it can manage images on a machine for you, and you can talk about running containers with it. So the first bit, this microphone situation is awful. So the first bit is, this is what you need to include in your node manifest to install Docker on a machine. You get class Docker, and then the class takes a bunch of parameters, which mirror pretty much the parameters that are in the Docker config file. This one says Docker should also listen on this TCP port. By default, Docker only listens on a Unix domain socket. We also want that. And we say where that goes, and we say we actually like to live dangerously and always want the latest version of Docker on that machine. So when you include that, things get set up for you, and you have the Docker daemon running on your host. The next thing you need is images, and there's a Docker image resource where you can say, I want the Ubuntu precise image on this host, and so every time Puppet runs, it will check whether the Ubuntu precise image is on that machine. If not, it'll do the Docker pull command behind the scenes to make sure it's there. You can also use that resource to build Docker images. For one, you can just point it at a Dockerfile, and it'll check whether the image is already there or needs rebuilding. If it does, it'll go through the Docker build incantations to do that. Also, you can point it at a directory. The temp Ubuntu image directory should contain a Docker file, but you might have some more files that need to go into that image build. And that's what the Docker image resource does. And then finally, to run containers, there's a Docker run resource. Naming is super inventive here. You say you want to run the App Server 2 container based on the Fedora 20. I'm slowly trying to steer away from Ubuntu given my Red Hat history, so we're doing Fedora 20 here. Run this container, and it takes about, you can set a whole bunch of parameters that again mirror the parameters that the Docker run command give. I don't want to go through all of them in detail, mostly to show that all the things you can do with Docker run are exposed at that level. But because you're doing it with Puppet, it's idempotent, and Puppet will, every time it runs, will check that that container is running. It's not a monitoring system, but it's some fail-safe to make sure the right containers are running. And finally, a fairly recent addition is Docker exec. You can also, similar to how Puppet has something called an exec resource that lets you just run a random, fairly random script or command. Docker exec lets you do the same thing, but inside a running container. So if there's any checking cleanup tasks, whatever that need to run, you can do that. If you want to see all of that kind of put together in action, Garen Action has a really cool example using vNext that does all that. What this module does is it creates a virtual machine with Vagrant, it installs Docker inside the virtual machine, it builds a Docker image, and then runs an ASP.NET Hello World app using the Linux version of .NET. This might be a great resource if you're curious how this can all be put together and used in practice. Okay, and if you have questions, by all means, just interrupt and raise your hand. I think we have enough time. Okay, the next part I wanted to talk about is image building. I said earlier that Docker doesn't really remove the challenges that config management sets out to solve, just shift them around a little bit. And the shifting is really that a lot of things that on kind of a mutable system, traditional system, happen at runtime, where you need to make changes at runtime, that those now happen at build time of your images. So the packages that get installed, the configuration files you lay down, and all that now happens at the time when you build your containers rather than at runtime. But you still want the ability to weave things together. And the first thing that people do when they want to use Puppet to build containers is something like this. I just stole it from James Turnbull. You run something called Puppet Apply. Who here doesn't know what Puppet Apply is? All right, Ryan's lying to me. But just for you, Ryan. So Puppet Apply gives you a way to run Puppet manifests from the command line. The picture I had earlier about a Puppet master and this whole talking back and forth between the node and the Puppet master, none of that you need with Puppet Apply. Puppet Apply is an interpreter for the Puppet DSL. You just put some Puppet manifests in the local file system, and Puppet Apply will just rattle through these and make changes to your local system. So it's a really low-key way to do something with Puppet, try something out without needing the whole infrastructure of a Puppet master. In this case, we're copying some modules into our image build, we're installing Puppet, and then we run Puppet Apply, pointed at those modules we just downloaded, and those modules presumably contain the Nginx module, and instantiate this Nginx class, which installs Nginx inside the container, the whole package, file, whatever. But since we're in build, we don't want the service to be running. That's what this parameter is about. And that's easy enough, but it's completely disconnected from a Puppet master. But as I said, an easy way to get started. Eventually, there's some prototype code, but it's not quite ready. We want to have like a Puppet command that saves you from writing the Dockerfile I just showed you, so that all you need to do is something like this, where you say Puppet Docker build, the name of the image you want to build, and then you point it at some manifest, and behind the scenes, Puppet then basically generates the Dockerfile for you. It actually will probably talk to the Docker daemon directly to do that image build rather than creating a file as an intermediate step. But to kind of shield you from, because this Dockerfile, if you're using Puppet Apply to build your images, is pretty much boilerplate. There's nothing, very little in this Dockerfile that is specific to the fact that we're installing Nginx. A lot of people don't have everything in containers. I don't know, actually, how many of you are using Docker in any capacity? And how many of you in production? All right, So you probably are doing something with computers right now. So you probably have other infrastructure that needs managing. And that's kind of something that people quickly forget, is that what you really want is a way to manage your traditional infrastructure and newer techniques like containers and all that in a way that at least gives you an overview of everything you have, right? You don't, from a management point of view, you don't want to distinguish too strongly between a web server that runs on a bare metal machine and a web server that runs inside a container. After all, they're still doing web server work. And so the first thing that you probably have, if you have traditional infrastructure, non-container infrastructure, is that a lot of people already have Puppet master somewhere. So ideally, you could just feed Docker image builds the same way you feed your current servers. And I've got a link at the end, but I wrote a little, and it's not a big script that supports this. This is that's what's getting copied into the image build right here. But this is, in a way, if you have a Puppet master, this is almost the only Dockerfile you ever need to write, because there's nothing in that Dockerfile anymore that's specific to what we're doing here, right? It looks totally generic. We add some scripts, and I'll talk about what's in the directory on the next slide. install Puppet and then run this little script there. What's in the directory copy in is this little wrapper script, little config file, and then SSL certificates. That's one of the things where the way Puppet is set up to talk to master right now is kind of, it's not terribly hard, but it's not super comfortable either that you have to keep track of these certificates to do your image builds. What this Puppet Docker script does under the hood is it sets up a few things. It copies those SSL certificates in the right place and then runs the Puppet agent, so that while you're building an image, you have an agent that talks to your Puppet master, and then the rest is just the normal flow of Puppet. That agent gets a catalog that gets applied now during your image build, not at runtime, but in the image build. So that catalog will talk again about packages that need to be installed, files that need to be there, and all that. And you control all that with your manifest the same way you control anything else in your infrastructure. And this config file is also not super complicated. The main thing is that it sets a certificate name, which is the name under which that agent will show up during the image build, so that in your manifest you can key it off that. So that in your manifest you can say something that shows up with this cert name. We're building this sort of image for it. And then I said a few facts that I use in my manifests to distinguish that this is actually an image build rather than a normal system checking in. Right, and so since this Dockerfile is total boilerplate, we also want to have a simple command line like this, so you don't have to worry about this Dockerfile. And in a way, invoking Puppet during image build then just becomes a somewhat different way to run the Puppet agent, and you can just build images, container images that way. All right, so that's kind of what we have today. There's a whole ton of things that we need to do, that we need to look at. There's a huge ecosystem that's growing up around Docker. I think the controlling Docker on a host and dealing with images is fairly solid, but kind of where it's moving with Docker is much more into things like Kubernetes, Mesos, and all that kind of orchestrating multiple Docker hosts. And there's a bunch of things that Puppet needs to integrate with. For example, Docker Swarm, which is Docker's abstraction API to control multiple Docker hosts. It's an abstraction around things like Kubernetes and Mesos and those things. So you go to Swarm and say, I want to launch these 5 containers, or this pod of containers, a set of interrelated containers, and then whatever backend Swarm is using figures out what host they actually go onto and all that. And that sort of integration is, from the Puppet point of view, again, it's very straightforward. We just did modules for AWS, which is very similar in spirit to this, where in your Puppet manifest you talk about, I want these EC2 instances, and then Puppet goes and checks whether these EC2 instances are already out there, and if they're not, it calls into the AWS API to create them. And integrating with Docker Swarm would work very, very similar. There's besides Kubernetes and Mesos, which are kind of on-premise solution, there's things like the AWS container service, I think they call it, and then Google Container Engine, which if Swarm doesn't kind of abstract their APIs, we would do that at the Puppet level, where you have a Swarm, whatever Docker Swarm resource to control a bunch of containers, and behind the scenes we would figure out whether to talk to the GCE API or the Kubernetes that you have running or something like that. Similar, there's something called Docker Machine, which is an effort to basically provide pre-built virtual machines, cloud instances, and all that are set up for running Docker. We're actually talking to Docker about making sure that it's easy, or that ideally we could have a Puppet agent in these things right off the bat, or if not, to at least make it really easy to get a Puppet agent in there. So that if you want to spin up a virtual machine cloud instance somewhere that you use for your containers, it's already ready for Puppet. One of the more difficult questions for Puppet or config management in general is runtime changes to containers. I'm not 100% sold on the idea that any container that ever comes up will run exactly unmodified from the way you build it. I think there's going to be a lot of cases where you need a little bit of personalization of those containers when they come up. It might just be to tell them you're the third web server in this application, or tweak some small parameters. One of the difficulties is that, for one, I think we're going to a world where we have a single service per container. For two, running a Puppet agent for each of the containers you're running would be crazy overhead. So we need to think what the right way is to have ideally one Puppet agent per Docker host that can then manage all the containers that are running on there, and use something like Docker exec or something like that to make changes in there. I mean, a really low-key way to at least get the personalization aspect into your containers is that you set up your containers to first run the Puppet agent once. When your container comes up, just run the Puppet agent once. It goes to the Puppet master, hopefully makes any changes that are needed for that specific container instance. And then after that, you start the actual service that you want to have running in there. So you don't have continual enforcement, but at least you have everything controlled by your manifests. The other kind of thing that would be really nice to have is a better correlation between the images you build with Puppet and the container instances you run of those images. If you build your images with Puppet, we already know a great deal about what's in those containers and all that stuff. If you build them against the master, all that stuff winds up in PuppetDB. So when you launch a container off that image, we already know what's in there, right? And what we're missing right now is the link between the running container and the image that we built. That's not a super difficult thing to get in there, but it's something we need to do. Okay, and that's pretty much all I have. Here's some materials about some of the stuff I talked about, the Docker module. This really, I'm almost embarrassed to show it, this little script that I use to run the Puppet agent during a Docker image build. And then here's a couple examples from Gareths, including that vNext example to run ASP.NET inside a container. All right, and with that, thanks for listening. Do you have any questions?
Can that module handle the upgrade of custom containers? Like if deploy it beyond
Right now, you would have to have 20 different resources for each of the containers you're running. So yes, because you're sticking 21 there. Yeah.
that shut down 20? Did that shut down 20? Would that be 20?
No, your actual catalog would talk about 20 different containers. 20 different Docker run resources. So and each of them is keyed off the name you give to your container at runtime. So it would it checks whether the container is running based on the name, and if it's not there, it'll start it. So if you add another container, if it's called container 20, that's not running yet. It'll just start it. Yes.
Does the Docker run resource PKs like the package resource does? I mean, if I have that name and I have it pinned to a particular tag or hash, and I go in and change that hash, will it then destroy that container and then relaunch it with the new hash? Or if I change one of the parameters, such as that I pass initially, will it change it and then go in and destroy it and relaunch it?
Yeah, I'm actually not sure if it. Basically, what I guess your question is if I manage the image in my manifest and I say pull the latest version of this image, and I have a container running off that image, would the Docker run resource notice that I have a newer image than what I'm running and restart it? And I'm not sure
if I tell it explicitly, I mean, in code.
Oh.
If instead of latest, I mean, if I say, Ubuntu and, a git hash tag or something like that, and I change that tag in my public code. Just like if I change, just like if I was version pinning a package.
Right.
If I change that, will the
I'm not sure if the Docker run thing will actually restart a container. If there's a different image tag hash, whatever. Right. The image will definitely get updated, but I'm not sure if the containers will actually get bounced. Have to look. Anybody else? Right. Thanks again.